NASA scientists have made a groundbreaking discovery in the solar system that has left them baffled. Using the latest technology and equipment, they have identified a mysterious structure that defies explanation. The discovery has the potential to change our understanding of the solar system and the universe as a whole. The structure is unlike anything that has been seen before and raises many questions about its origin and purpose. Greetings and welcome to my channel. Today, we're going to talk about mysterious structures discovered by scientists. NASA scientists are now working tirelessly to study and analyze the structure to unravel its secrets and unlock its mysteries. This discovery is a testament to the power of scientific exploration and the boundless potential of human curiosity. But first, if you haven't subscribed, please subscribe to my channel and enable the notification bell so you can see more interesting videos like this. So let's dive in and learn more about this fascinating development. The Fermi Gamma Ray Space Telescope, launched in 2008, is a space observatory that is designed to study gamma rays, the most energetic form of radiation in the universe. Gamma rays are produced by some of the most violent and energetic events in the universe, such as supernova explosions, black holes, and pulsars. The Fermi bubbles are a mysterious phenomenon that was discovered in 2010 by astronomers using the Fermi Gamma Ray Space Telescope. These bubbles are two huge lobes of gas that emit gamma rays, extending from the center of the Milky Way galaxy to a distance of about 25,000 light-years in both directions, forming a shape resembling two soccer balls stuck together. The bubbles are expanding at a speed of 2.2 million miles per hour, or 3.5 million kilometers per hour, making them one of the fastest-moving objects in the Milky Way. They are also extremely energetic, emitting gamma rays with energies up to several trillion electron volts, making them the most energetic gamma rays ever observed in the Milky Way. The origin of the Fermi bubbles is still a mystery to astronomers because they had not been detected before. This is because the gamma rays emitted by the bubbles are relatively faint and are mixed in with a diffuse background of gamma rays produced by other sources in the Milky Way. It was only with the high sensitivity and resolution of the Fermi telescope that the bubbles were able to be detected. One possibility is that they are the result of a massive eruption from the supermassive black hole at the center of the Milky Way, which could have released huge amounts of energy and matter into space. Another possibility is that they are the result of a burst of star formation in the Milky Way's central region. The Fermi bubbles are important because they provide new insights into the structure and evolution of the Milky Way galaxy. For example, they are thought to be a result of a violent event that occurred in the past, and their shape and orientation can provide clues about the nature of that event. Additionally, the gamma rays emitted by the bubbles can be used to study the distribution of gas and cosmic rays in the Milky Way, as well as the dynamics of the galactic center. The Fermi bubbles have provided astronomers with a new tool despite their mystery, to study the structure and evolution of our galaxy. By studying the gamma rays emitted by the bubbles, astronomers can learn about the distribution of gas and cosmic rays in the Milky Way, as well as the dynamics of the galactic center. The Fermi bubbles are also a reminder of how much we still have to learn about the universe, and how much more there is to discover. Despite these insights, there is still much that is unknown about the Fermi bubbles. For example, their exact age and the mechanism behind their creation are still a mystery. There are several theories about their origin, including that they are the result of a massive starburst event in the galactic center, or that they are the result of energy released by the supermassive black hole at the center of the Milky Way. DIFFUSE mission. The Fermi researchers discovered that gamma rays, which are highly energetic members of the electromagnetic spectrum, interact with light and gases in the Milky Way. Gamma rays do not reflect off objects like visible light does, instead, destructively penetrate them. Gamma radiation passing through the human body, for example, can immediately damage chromosomes and cause ionizations that can wreak havoc on tissue. Shielding is required to stop potentially deadly gamma rays, such as several inches of dense shielding like lead or even several feet of concrete. However, the good news is that few gamma rays reach the Earth's surface, as our sun emits less dangerous forms of light without the toxic mixture of X-rays and gamma rays. Gamma radiation flying around interstellar space is from very violent and energetic events, such as supernova, and the likelihood of a nearby gamma ray burst striking Earth is low. The Fermi bubbles, which are two supergiant balls of gamma rays spanning almost 50,000 light-years from end to end, were created by a cataclysmic and mysterious event. the configuration of the Fermi bubbles above and below the Milky Way center point to a suspect, our supermassive black hole called Sagittarius A*. The enormous amount of energy it took to unleash these two supergiant balls of gamma rays is still puzzling to astronomers, but they are studying clues to better understand the phenomenon. Sagittarius A. The discovery of the Fermi and Eroicita bubbles has provided astronomers with a new puzzle to solve. These bubbles, which extend over 70,000 light-years above and below the center of our Milky Way galaxy, are made up of high-energy radiation. They were first observed by the Fermi Gamma-Ray Space Telescope in 2010 and later confirmed by the Eroicita X-ray satellite in 2020. The source of these bubbles is believed to be the supermassive black hole located at the center of our galaxy, Sagittarius A. The black hole is estimated to have a mass of 4 million times that of our Sun and is in a prime position for study, located only 26,000 light-years away from Earth. Astronomers have observed that supermassive black holes can sometimes eject large jets of ionized matter from galactic centers at near-light speed. These jets can be propelled by massive shockwaves, which heat and compress gas on both sides of the galactic core. This process can create an hourglass-shaped structure, which, when the shockwaves break out, can result in bubbles of high-energy radiation being propelled in opposite directions. The process of creating these bubbles may have lasted up to 1 million years, starting with an almost unimaginably powerful blast. Researchers trust that the power supply in the back of the introduction of those bubbles is attached to many deep questions in astrophysics. There are several theories regarding the cause of the bubbles, including the possibility that an unfortunate star drifted too close to Sagittarius A and was torn apart, releasing enormous levels of gravitational energy in an instant. The discovery of the Fermi and Eroicita bubbles has helped astronomers to better understand the interaction between supermassive black holes and their host galaxies. These black holes, believed to be at the center of virtually every large galaxy, grow in a controlled manner in their host galaxies, instead of wildly out of control. Further studies of these mysterious bubbles may go far in revealing this relationship. However, the strange subatomic interactions occurring inside the bubbles, which have been observed by the IceCube Neutrino Observatory in Antarctica, continue to perplex astrophysicists. According to the research conducted by various observatories and simulations, the Fermi and Eroicita bubbles were likely formed by an enormous explosion from the supermassive black hole at the center of our galaxy, Sagittarius A. This explosion sent out shockwaves that propelled jets of ionized matter in opposite directions, resulting in the hourglass structure that formed the bubbles. The process of bubble formation would have taken up to 1 million years, during which the shockwaves would have had to plow through hot gas on both sides of the galactic core. As they heated and compressed, the hourglass structure formed, and the shockwaves roared into space in both directions, resulting in the Fermi and Eroicita bubbles. These bubbles are significant because they provide clues about the interaction between supermassive black holes and their host galaxies. Astronomers are interested in understanding why these black holes grow in a controlled manner in their host galaxies instead of wildly out of control. While the origin of these bubbles may have been identified, researchers continue to study them to understand the strange subatomic interactions that are occurring inside them. The discovery of high-energy neutrinos inside the Fermi bubbles is particularly interesting because neutrinos are known to be produced in extreme environments such as black holes and supernova. This suggests that there may be some kind of exotic processes taking place within the bubbles. One theory is that neutrinos are produced by the decay of dark matter particles. Dark matter is a hypothetical form of matter that is thought to make up about 85% of the total matter in the universe, but which does not interact with light and is therefore invisible to telescopes. If the neutrinos are indeed produced by dark matter decay, this would be an important step toward understanding the nature of dark matter. Another possibility is that neutrinos are produced by cosmic rays, which are high-energy particles that travel through space at close to the speed of light. Cosmic rays are thought to be produced by supernova explosions and other violent events in the universe, so their presence within the Fermi bubbles could provide important clues about the history of our galaxy. Studying the Fermi and Eroicita bubbles and their connection to the supermassive black hole at the center of our galaxy can provide us with valuable information about the role of black holes in the universe and how they interact with their host galaxies. It can also help us understand the processes involved in the formation of these bubbles. and the strange subatomic interactions occurring within them. This knowledge could contribute to advancements in the field of astrophysics and our understanding of the structure and evolution of the universe. What do you think about these massive, perhaps lethal radiation bubbles that are erupting from our Milky Way? How much stranger is our cosmos becoming with each new finding? Tell us in the comments section. Thank you for tuning in to our video today. Don't forget to like, share, and subscribe to our channel for more exciting news and updates from the world of science and beyond. See you in the next video.